Hello everyone, welcome back to Embed System course. So we are in chapter number 2, that is 8051 timers and serial port programming in C. So as I told you, there are two parts in this chapter, that is 8051 timers programming in C, and second part is serial port programming in C. So we finished with first part, that is 8051 timers programming in C in last or previous lecture number 5. Okay, so from this lecture onward, that is lecture number 6, we are going to study serial port programming in a C of 8051 microcontroller. Okay, so this is a second part. So first we will study basics of serial communication, then how to connect 8051 serial port to RS-232 port, which is connected to serial devices. Okay, that is a serial communication standard RS-232 that we will study. And then last part is we will program serial port of 8051 for serial transmission and reception. Okay, so first in this lecture, lecture number 6, we will study about serial data communication. Okay, introduction to serial data communication, and then we will study how to connect serial port of 8051 to RS-232 port that is normally available on various devices like computer and other uh, devices. Okay, to have serial communication with it. So in first part, that is a introduction to serial data communication, we will see basics of serial communication first, then asynchronous serial communication, which is available in 8051, then data transfer rate, then we will see about RS-232 standard and max 232 converter that is necessary while interfacing 8051 serial port with RS-232 port. Then we will study various types of connectors uh, available in RS-232 standard like DB25 and DB9 connectors. And then we will see the simplest connection possible between personal computers, serial port and microcontroller. Okay, microcontroller serial port. So let us see about serial data communication. So as you know, computers can transfer data in two ways. Okay, so in its simplest form, that is computers, we can say microcontrollers or microprocessors can transfer data in two ways. Okay, first is serial transfer. So in that case, in between sender and receiver on a single line, uh, bits of data transmitted, okay, serially, or can be received by this receiver serially. Okay, that is serial transfer of data. Okay, so obviously that data is digital, that is in the form of zeros and ones, so that can be transmitted serially on a single line from the sender to a receiver. Okay, so this center will just put zeros and ones continuously after some fixed interval of time, and receiver will receive these bits, okay, sequentially, serially on this pin, okay, after a fixed interval of time. Okay, so this will happen in serial transfer of data from the sender to receiver. In case of parallel transfer, which is a common method to interface any peripherals, okay, with microprocessor or microcontroller. Okay, so these peripherals are near to that microprocessor and microcontroller, so it is possible to have parallel interfacing. Okay, so what does this parallel transfer or parallel interfacing between sender and receiver? So instead of a single line, number of parallel lines are used. Okay, for example, here D0 to D7 means eight lines are connected between sender and receiver, and on these 8 lines the sender can send 8 bits of data parallelly. Okay, so such a transfer is called as parallel transfer. Okay, so such parallel transfer is feasible when sender and receiver are near to each other. Okay, that is that distance is limited between sender and receiver. Okay, but if sender and receiver are far away, okay, that means distance between sender and receiver is as increases, then it is not feasible or possible to have parallel transfer of data, because in that case uh, we need to have parallel lines. Okay, like here D0 to D7, to carry D0 to D7 data, 8 parallel lines are required in between sender and receiver. Okay, and in long distance communication, it is not possible to have such eight lines between sender and receiver. Okay, so parallel transfer, this type of method is not feasible uh, to transfer data at long distances. Okay, but serial transfer is feasible for that. Okay, so that is difference between serial transfer of data and parallel transfer of data. Okay, so if sender and receiver are two uh, computers, okay, so these two computers can communicate with each other, okay, by using this single line. Okay, so not necessary sender and receiver should be uh, computers, it could be any data terminal equipment. Okay, so that is a difference between serial transfer and parallel transfer. So we are going to study serial data communication. Okay, now we will concentrate on this part, that is serial transfer. So this serial transfer between sender and receiver, that could be of any one of these three types. Okay, so that means serial data communication could be of these three types. First is simplex, second is half duplex, and third is full duplex. Simplex means only a serial data transfer is possible in one direction. Okay, like shown in this figure. So this sender can send only data to this receiver, and receiver can only receive data. Okay, that is simplex. Half duplex means at a time this can send data to this receiver, or receiver, this receiver can also send data to this uh, sender. Okay, means two way serial data transfer is possible, but one at a time. Okay, so that is a half duplex. So example, analogous example of simplex is radio, FM radio communication, or FM or AM radio communication, in which there is only communication in one way. Okay, the example of half duplex is a wireless set system in police department. So that can operate in one direction at a time. Okay, and last type of serial transfer is full duplex, means um, parallelly data transfer is possible in both the directions. Okay, and analogous example of this full duplex is that is a telephone or mobile phones, by which we can call each other, and we can talk, means both person can talk at a time, and both can listen their conversation. Okay, so that is full duplex type. Now serial data communication uses two methods, okay, to transfer data. Okay, so these are synchronous method and asynchronous method. In case of synchronous method, transfer of block of data uh, happens at a time. Okay, means in between the sender and receiver, a block of data, that is number of bytes, transfer takes place at a time. Okay, but in case of asynchronous method, transfer of single byte happens at a time. Okay, means the sender can send a byte at a time. Okay, after that byte is received by this receiver, then sender can send next byte. So that is a asynchronous method. Okay, so that byte that the sender is transmitting to this receiver, that is normally framed, between start and stop bit before transmission. Okay, so suppose that a single byte means 8 bits. So these 8 bits are framed between start and stop bit. Okay, for example, if we assume one start bit and one stop bit, means total number of bytes, okay, transmitted at a time will be 8 plus 2, that is 10 bits. Okay, number of bits transmitted, okay, that is 10 bits. Means to transmit 8 bits of data, that is single byte of data, 2 more bits are required. Okay, so we are going to study this asynchronous method in a details, because that is available in 8051 microcontroller serial port. Means 8051's serial port can transmit or receive data by using this asynchronous method. Okay, so now we will focus our study on asynchronous serial data communication. So as I told you, asynchronous serial data communication is used for character oriented transmissions. So character oriented transmission in the sense, for example, there is a text file, and if we want to transmit data in that text file serially, then we can use this asynchronous serial data communication, because smallest unit in that text file is a character, single character. Okay, so these characters in text file sequentially can be transmitted by using this asynchronous serial data communication. Okay, so that single character can be represented by a single byte. Okay, as we know, each character in is having equivalent ASCII code. Okay, so uh, by using that code, okay, we can represent every character by using that code, and that code can be uh, transmitted, okay, by using this asynchronous serial data communication. So how that is that character is transmitted? So ASCII code of that character is placed between start and stop bits. Okay, and this is called as actually framing. Okay, so framing is used uh, so that that byte, okay, or character being transmitted, that can be satisfactorily received at the receiver end. Okay, so for that purpose framing is used. Means in the start bit is added, and in the end stop bit or stop bits are added. Okay, so that at the receiver end, receiver can understand that when that 8 bits of data or 1 byte of data is starting and ending. Okay, uh, so start bit is normally 1, that is logic 1. Okay, uh, sorry, start bit is always 0. Okay, means logic 0, and it is called as space, and it is normally 1. Okay, one start bit is used, and that is logic 0 space. And stop bits could be 1 or 2, and stop bits is always 1, and that is called as mark. So in serial data communication, logic 0 is called as space, and logic 1 is called as mark. Okay, start bit is always 1. Okay, and stop bits can be 1 or 2. Okay, now how this framing of character, that is to be transmitted serially by using asynchronous method of serial communication, that is done. Okay, so see here, this diagram illustrates the framing of character. For example, here D0 to D7, 1 2 3 4 5 6 7 8. Okay, so these are 8 bits of data, that is character to be transmitted, that is 10000010, that is a ASCII, suppose ASCII code of some character. Okay, so when there is a no communication in on serial port, okay, or channel, then signal on that channel will be marked. Okay, so that means at logic 1, mark means logic 1. Okay, sorry. Okay, so see here, so 1 means that is called as mark, and 0 means that is space. Okay, so here when there is no communication, okay, so when there is no transfer or communication, the signal is high, that is mark. Okay, which is referred to as mark. Okay, so when there is no serial communication happening, okay, so signal on that communication channel, okay, will be mark, that is high, that is logic 1. Okay, and when that communication starts, okay, so this time period, this time period is called as 1 bit period. 1 bit period. Okay, so this time is called as 1 bit period. That is the time for which signal should be uh, there. Okay, either 0 or 1, or space or mark. Okay, that should be maintained. Okay, because that will decide the data transfer rate. Okay, and depending on data transfer rate selected, this period varies. Okay, so this is fixed. Okay, so for this minimum amount of time, the signal should be there on that serial port or communication, serial communication channel. Okay, so uh, serial transfer of data starts with start bit, which is a space, means logic 0. So it will remain 0 for this 1 bit period of time. Okay, and then that is actual character byte will be placed serially. Okay, so first LSB, that is D0, so this is LSB, and this is D7 is MSB. Okay, so first this one will be put on that serial channel. Okay, that is a single line, and it will be there for 1 bit of time, that is this time period. Okay, then next, that is bit D1 will be put on that uh, channel or serial port, then next, then next, then next, then next, and then last MSB bit. Okay, in this way, serially, these bits are put on serial port or channel. Okay, and after this D7 bit, there will be a stop bit. Okay, stop bit is always 1. Okay, so uh, after D7 bit, okay, so that stop bit means mark. Okay, that will be put. Okay, and after that, again signal will go low. Okay, that is, it will become space. Okay, in this way, these 8 bits of data, 8 bits of data to be transmitted, okay, that is D0 to D7 bits, are framed between the start bit and stop bit. Start bit is space, that is 0, and stop bit is 1, that is mark. Okay, so total number of bits will be transmitted or on serial channel, okay, or serial port will be 10. Okay, so these character bits are 8 plus 1 start bit and 1 stop bit. Okay, so total 10 bits will be transmitted, and these 10 bits are used to transmit how much data, that is 1 byte of data. Okay, in this way framing is done, so that at receiving end, that byte or character will be received satisfactorily, because uh, a receiver will understand when it will get signal 0, means it will um, expect a byte or character data. Okay, then it will get that data, and after that, this ninth bit, if it is 1, it understood that one character data or 1 byte of data is received. Okay, then it will move that 8 bits of data or character into some uh, safe place or some internal register. Okay, so this is framing of a character in asynchronous serial data communication. Now we will talk about data transfer rate, means what is meaning of data transfer rate. Okay, so the rate of transfer in serial data communication is stated in BPS, that is the unit of data transfer rate, that is the rate at which data will get serially uh, communicated or transmitted that is called as data transfer rate. So it is stated in bps, that is bits per second, that is number of bits being transmitted per second. Okay, another widely used modern terminology for data transfer rate is called as baud rate, and baud rate is defined as the number of signal changes per second. Okay, so on communications channel, serial communication channel, suppose so in between these two devices, okay, so these are two serial devices, means in between these two devices serial communication is happening. Okay, and on this communication channel, okay, signals are changing depending on data being transmitted like this. Okay, so signals are switching in between 0 and 1. Okay, 0 and 1, 0 0 1, 0 1, 0 1, 0 0, so on. Okay, so how much these signals are actually uh, changes, okay, in between zeros and ones. Okay, so that is called as baud rate, that is called as baud rate. Not necessarily every bit on this communication channel, okay, is data. Okay, some of these bits are overhead bits. For example, what are overhead bits? Overhead bits are like for start and stop bits. Okay, so these are called as overhead bits that are necessary to transmit actual data. Okay, for example, to uh, to serially transmit one character, we require one start bit and one stop bit. Okay, so these two bits are called as overhead bits, means out of 10 bits being transmitted, 2 bits are overhead bits. Okay, so that is uh, called as baud rate. And as per communication channel is concerned, the baud rate and bps are the same, and we use the terms interchangeably. The data transfer rate of a given computer system depends on communication ports in system. If we assume this is as a computer system, okay, this is pc, okay, and this is another serial device. Okay, and if we are having communication between this computer system and this serial device, so how much data transfer rate is possible between these two devices? It depends, okay, on communication ports in the system of this pc and in this serial device. Okay, so it could be anything, it could be another pc. Okay, so in case of IBM PC XT, okay, uh, IBM PC XT could transfer data at the rate of 100 to 9600 bps. Means if this PC is IBM PC XT, okay, so these are outdated now. Okay, so that rate could be possible is in between 100 to 9600 bits per second. Okay, maximum 9600 bits per second data rate could be possible on this channel if this PC is IBM PC XT. Okay, if this PC is Pentium, then the data rate possible as high as 56k bps, means 56,000 bits per second. With this data rate, communication is possible between this Pentium PC and other compatible serial port device or another Pentium PC. Okay, so in case of asynchronous serial data communication, the baud rate is limited to 100 kbps. So as I told you, so communication method possible, okay, on serial port, that could be asynchronous or synchronous. So in case of 8051, that serial port is having asynchronous serial communication, and in case of asynchronous serial communication, maximum baud rate or data rate that is limited to 100 kbps, means 100,000 bits per second. This is the maximum data rate or baud rate with which communication is possible, okay, in asynchronous serial data communication. So this is about data transfer rate. Then very important part, that is uh, RS232, sorry, RS232 interfacing standard. Okay, so as I told you, in serial communication, so like this serial communication could be possible. So this is one device and this is another device. Okay, and this is a communication. Okay, for example, for transmission, one line is there, and it could be possible to have another line for reception. Okay, so these are called as actually uh, DTE and DC, DTE and DC at this end, and here also we can have DTE and DC. Okay, so if we separate this, uh, we can draw one more block here and here also. Okay, so this is DTE and this is DCE at this end, and this is DCE and this is DTE at other end. Okay, so data communication equipments, these are called as data communication equipments which communicates with each other serially. Okay, so these are classified as DTE and DC. DTE refers to terminals. Okay, so DT refers to terminals and computers that send and receive data. Okay, so what is this DTA? DT could be a computer system or any other device. Okay, so which just sends or receives data. Okay, and this DT sends data to DC, and DC, what DC will do? So DC means data communication equipments such as modems that are responsible for transfer of data. Okay, so actually whatever communication happens on serial port, okay, on serial port in between two DTEs. Okay, so this serial communication is under the control of these two DCEs, data communication equipments, which are responsible for actual communication on this serial data communication channel or serial port. Okay, so that is the job of data communication equipment. So these DCEs just receive data from DT. Okay, or these two DCs supplies received data to respective DTs. Okay, so these DCs are actually responsible for actual communication of data on communication serial communication channel or serial port. Okay, so that is concept of DT and DC. Okay, now to allow compatibility among all serial data communication equipments like DTE and DCs, okay, being manufactured by different manufacturers. Okay, so these DTs and DCs are being manufactured by various manufacturers. Okay, so I can use any manufacturer's DT or DC, okay, in my system. Okay, if these DTs and DCs are having interfacing standard called as RS232. Okay, so to have compatibility among different data communication equipments being manufactured by different manufacturer, one standard was there or introduced, that is called as RS232 standard. Okay, so that any data terminal or data communication equipment I can use. Okay, okay, so that is the concept of this interfacing standard called as RS232. Okay, and it was set by EIA, that is Electronics Industries Association, in 1963. Further, it is modified as per requirement and introduced as RS232A, RS232B, RS232C, etc. Okay, and RS232 standard is not compatible with TTL, transistor logic. Okay, for example, various chips, okay, we use. So these chips follows TTL standard. Okay, so in TTL standard, logic 0 means what? Logic 0 means logic 0 means 0 volt. Okay, logic 0 means 0 volt, and logic 1 means what? It is 5 volt. Okay, so that is a TTL. In case of TTL standard, 0 means 0 volt, 1 means 5 volt. But in case of RS232, these are not the logic levels. In case of RS232, logic levels are: logic 1 means -3 to 25 volt, -3 to -25 volt, and logic 0 means +3 to +25 volt. Okay, for example, your 8051 microcontroller follows TTL standard. Okay, means on its pin. Okay, for example, one particular port pin, if it outputs 0 volt means it is logic 0, if it outputs 5 volt means it is logic 1. Okay, but that is not the case in RS232 standard, because RS232 invented before TTL logic. Okay, RS232 standard was introduced in 1963, and at that time there was these no TTL standard was there. Okay, so it invented afterwards. Okay, so RS232 logic levels are -3 to -25 volt means logic 1, and +3 to +25 volts means logic 0. Okay, so that means when we want to connect, okay, so this RS232 compatible data um, communication equipment with 8051 serial port, okay, that is to connect RS232 to microcontroller system, we must use voltage converters such as max 232, okay, to convert TTL logic levels to RS232 voltage levels, and vice versa, means opposite. Okay, so what this max 232, it is a voltage converter, okay, that should be connected in between 8051 microcontroller serial port and RS232 port of any data communication equipment. And what this max 232 converter will do, it will convert TTL logic from 8051 microcontroller to RS232 logic, and it will convert reverse it convert uh, logic levels from RS232 to TTL. Okay, so that is the job of this max 232 line driver, okay, or voltage converter, that is used to interface microcontroller with RS232 port. Okay, so that RS232 port, for example, your PC, every personal computer system is having RS232 port, that is COM port. Okay, and it could be available in terms of DB25 connector on your PC, or DB9 connector. Okay, DB25 means it is like this: 25 number of pins are there. Okay, and the shape of that connector is like D. Okay, D. Okay, so the name, that is D. Okay, and 25 pins are there, so 1 to 13 pins, and 14 to 25 pins. Okay, so such connector is available on personal computer, so that is called as RS232 port, and also known as COM port, that is serial communication port. Okay, so all these out of 25 pins, only few pins are used in actual serial communication. So afterwards, instead of putting this DB25 connector on PCs, so normally that is changed to DB9 connector. Okay, so instead of having 25 pins, since not all these out of 25 pins are used in actual serial communication, so that DB25 connector, okay, so that is replaced by DB9 connector, in which again shape of that connector is D, but number of pins available are 9. Okay, 1 2 3 4 5 6 7 8 9. Okay, and these are these pins and their functions. Okay, so pin number 1 is data carrier detect, pin number 2 is received data, 3 is transmitted data, 4 is data terminal ready. Okay, but actually in actual serial communication, even these nine, all the 9 pins are not used, only 3 pins like RxD, TxD, and ground, that is used. for actual serial data communication. Okay, so that is written here. Since not all pins are used in PC cables, IBM introduced DB9 version of the serial IO port as follows. Okay, so that is DB9 RS232 DB9 connector. Now, how to connect personal computers that RS232 port, that is communication port or serial port, okay, with serial port of microcontroller, any microcontroller. Okay, so the simplest connection between PCs, RS232 port or COM port and microcontroller requires minimum 3 pins. Okay, that is a TXD pin, RXD pin, and ground. Okay, and that is shown here. So these are two DTEs. These are connected. Okay, via these 3 pins. So TXD of this DT is connected to RXD. TXD means transmit data, and transmitted data on this pin will be received by RXD pin of other DT at other end, that is receive data. Okay, and TXD pin of this DT at other end is connected with RXD pin of this DT at this end. Okay, and common ground pins of these both the DTs are connected together. Okay, so that means the simplest connection between PC's RS232 port and serial port of microcontroller is like this. Okay, only 3 pins are interfaced. Okay, TXD, RXD, and ground pins of DT are connected with TXD, RXD ground pin of another DT. Okay, so for that 8051 has 2 pins, that is the RXD, that is port number 3 pin number 0, and TXD, that is port number 3 and port number 3 pin number 1 for asynchronous serial communication. Okay, and these pins are TTL compatible. That means in case of 8051 these RXD and TXD pins are TTL compatible, means on RXD and TXD pin, okay, data that is voltage level 0 means logic 0, and voltage level 5 volt means logic 1. So that is TTL standard. Okay, so therefore we required max 232 line driver to make them RS232 compatible. Okay, because we are going to interface PC's RS232 port with microcontrollers serial port. So in between we required max 232 to convert RS232 logic levels to TTL and TTL logic levels to RS232. Okay, so that is the way we can interface PC's RS232 port with serial port of 8051 microcontroller. Okay, so actual connections of 8051 to RS232 port of PC or any other device is shown here. So for that max 232 line driver or voltage converter is used like this. Okay, so this is 8051. So 2 pins, that is TXD and RXD of 8051, that acts as serial port of 8051, that is pin number 1 of port 3 is TXD and pin number 0 of port 3, that is RXD. Okay, so this TXD pin is connected to pin number 11 of max 232 and pin number 11 is T1 in. Okay, T1 in, and RXD pin of 8051 is connected to pin number 12 of max 232, which is R1 out. Okay, means on this pin data will be outputted by max 232 received from this DB9 means RS232 port of PC or any other device. Okay, and on this pin, that is max 232 11 number pin, that is T1 in, it will receive data from 8051 from TXT pin. Okay, similarly at other end pin number 14 is connected to pin number 2. Okay, 14 is what? 14 is T1 out. Okay, it is connected to pin number 2 of this DB9 means it is actually RXD. Okay, so let us check. Pin number 2 is RXD, isn't it? Pin number 2 is RXD and pin number 3 is TXD. Pin number 3 is TXD. Okay, so this is RXD pin and this is TXD. This is TXT. So this is DB9 connector, means RS232 port of PC or uh, any other data terminal equipment. Okay. Uh, so pin number 14 is what? That is T1 out, means max 232. It will receive data. Okay, via this 12 number pin, and it will output it to pin number 14. Okay, similarly it will receive data on 13. 13 is what? That is R1 pin, R1 in pin. Okay, so this DB9 or RS232 port will output data on this TXT pin, and that will be received by max 232, and it will be outputted on pin number 11. Okay, now here, when this data will be received by this max 232 on RX via this 12 number pin, okay, which is connected to RxD pin of 8051, it will convert this logic level. Okay, so here logic level available are TTL, it will convert it to RS232. Okay, and it will put that signal on pin number 14. Similarly, from this RS232 port, it will receive data on 13 number pin, that is connected to TXD pin of RS232 port, and here logic levels are available are that is RS232 logic levels. It will convert these logic levels to TTL, and it will put that data on pin number 11, which is connected to TXD. Okay, in this way this max 232 acts as voltage converter. It converts logic levels of data received from 8051 to RS232 logic levels and put on 40 number pin, and it will convert the logic levels of signals received from this RS232 port, okay, on pin number 13, okay, to TTL logic levels, and put that TTL logic levels on pin number 11, and it will be it is connected to TXD pin of 8051, and it will be received by 8051. In this way max 232 is used, okay, to convert these logic levels from 8051, okay, that is TTL logic levels to RS232, and RS232 logic levels to TTL, so that we can have interfacing between uh, serial port of 8051 and RS232 port of PC or any other data terminal equipment. Okay, so by using single max 232 chip, okay, so actually there are two sets of line drivers, okay, T1 in, R1 out, and T1 out and R1 in. So this one set is used to interface uh, between two data terminal equipments, okay, and another set I can also use to interface another set of data terminal equipments. Okay, so it has, since it has two sets of line drivers, okay, so this T2 in, T2 out, R2 out, R2 in, so this one set is used to interface between two data terminal equipments. Okay, in this way max 232 single chip allows to interface two sets of data terminal equipments. Okay, so that is the way we can connect 8051 serial port with RS232 port of PC or any other data terminal equipment or device. Okay, so this is about introduction to serial data communication, okay, and connection of 8051 to RS232. Okay, first we saw introduction to serial data communication. Under that we studied basics of serial communication. Then we saw what is asynchronous serial communication, which is there in case of serial port of 8051 microcontroller. And after that we saw data transfer rate, what is BPS, what is baud rate. Okay, then we saw RS232 standard. Then we saw what is necessity of max 232 voltage converter or line driver. Okay, then we saw DB25 and DB9 connector, and then simplest connection between PC and microcontroller we saw by using three pins TXD, RxD, and ground in between two data terminal equipments. Okay, and then actually we saw interfacing between serial port of 8051 with RS232 port of PC or of any other data terminal equipment or device. Okay, for that we used max 232 line driver. in between 8051 serial port and uh, RS-232 port of PC or any other device. Okay, so this is about introduction. In next lecture, we will actually study serial port of 8051 and its programming in C. Okay, so any doubt we can have discussion in our live session. Okay, so I will stop here. Thank you.